Good morning, my name is B. Santosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. Today my topic is Basics of Spatial Filtering. So what is spatial filtering? What is spatial filtering? Spatial filtering is a technique is used directly on pixels of an image. And here I'm using mask technique for filtering. So mask is usually considered to be added in size so that it has specific center pixel. This mask is moved on the image such that the center of the mask traverses of the all pixels. So what are the classification of the basic linearity? There are two types of the linear spatial filtering, non-linear spatial filtering. So suppose the input image is noisy. So my output image noiseless image. So the output image is a noiseless. How can I get the noiseless image? So here I am using spatial filtering technique to reducing the noise, or remove noise. So here spatial filtering is used to remove the noise. So it is directly on the pixel of an image. So it is directly approaching the each pixel. So what is the intensity level of the original image? What is the present intensity level? What we have to change? What is the need to change? Okay, that we need. And here mask is a technique using in a filter process. Okay, so mask is usually considered to be added in size so that it has a specific center pixel. This mask is moved on the image such that the center of the mask traverses all images pixels. So what are the classifications? Here linear and non-linear spatial filterings are there. So what is a linear filter and what is a non-linear spatial filters? We'll discuss. Okay. So what is the filters in spatial domain? So in the spatial domain I'm using filter. What is a need? So spatial filters use it to different masks, kernel, templates or windows. There is a one-to-one correspondence between linear spatial filters and filtering in a frequency domains. Okay. So spatial filters can be used for linear and non-linear filtering. That is a frequency domain filters just for linear filtering. So here spatial domain I'm using the filter technique. Okay, in the spatial domain I'm using filter. So filters in spatial domain. So what is the spatial domain? Here different masks. So when I'm using the filter, I'm using definitely mask technique. Here I'm using mask technique to remove the noises. I'm in the filters I'm using mask technique. Okay, it is different masks, that is kernels and templates or windows. There is a one-to-one correspondence between linear spatial filters, filtering and frequency domain. So spatial filters can be used for linear and non-linear filtering. So where I'm using, so it is a frequency domain filter just for linear filtering. When I'm using the frequency domain, I'm using linear filtering. So the mechanics of a spatial filter in the filtering consist of neighborhood or small rectangular predefined operation that is performed on the image pixel. Filtering creates new pixel with correspondence equal to the coordinates of the center of the neighborhood and whose values is the result of the filtering operation. So what are the mechanics of the spatial filtering? So spatial filter consists of neighborhood or small rectangular and predefined operation that is performed on the image pixel, and filtering creates new pixel with coordinates equal to the coordinates of the center of the neighborhood and whose values in the result of the filtering operation. Okay, suppose I am taking one image. What are the coordinates are there? Here I am taking x-axis, I am taking y-axis. So the neighborhood of the small rectangle and a predefined operation of the performed image, and filtering creates new pixels equal to the coordinates of the center of the neighborhood and whose values result to the filtering operation. So what are the coordinates are there? Here x and y. So I am taking x plus 1 comma y or x minus 1 comma y. x comma y plus 1, x comma y minus 1. So these are the 4 coordinates I'm using. Okay, here. So the coordinates of the center of the neighborhood and whose values of z are the filtering of the operation. So in the operation performed on the image pixel is linear. Then the filter is called linear spatial filter. Otherwise, the filter is a non-linear. Okay. So the operation is performed. What is operation? The filtering operation I'm doing here. The operation performed on the image pixel is linear. Then filter is called linear. Okay. So if otherwise it is a non-linear. So when the operation is performed as a linear, then it is a linear filter. If I'm not applying the linear filtering, then it is called non-linear filtering. Okay. So in the present, the mechanics of the linear spatial neighboring, it is a 3x3 neighborhood. The response output g of x comma y of the filter at any point x comma y. So g of x comma y output equal to, suppose I am taking t of x comma y. So here it is the output and it is the input. So what is the t function I am using? It means filtering. Okay, filtering means linear or non-linear. Okay, so when the output g of x comma y equal to t of x t into f of x comma y. So in the t function, what is the t means? Here I am applying filtering process. Okay, that is a linear or non-linear. So when I'm using the filter or linear or non-linear, the filtering here I'm using mask technique. Okay, here the process is a mask for applying the filtering process. In the image is the sum of products of the filter coefficients and image is pixel. So suppose I'm taking one image, it is a 3x3. Okay, so what are the coordinates means? It is the x coordinate and it is a y coordinate. So what is the origin means? X comma y are the origins. So the 3x3 neighbor is a x comma y. The image has a spatial domain. Okay, so here the middle one is a x comma y. Here x plus 1 comma, sorry, x minus 1 comma y. Here x plus 1 comma y. So like this. So here the output g of x comma y equal to w of minus 1 comma minus 1 into f of x minus 1 comma y minus 1 plus w of minus 1 comma 0 into f of x minus 1 comma y plus w of x 0 comma 0 f of x comma y w 1 comma 1 f of x plus 1 comma y plus 1. So here I am taking 4 neighbor. So what are the probabilities are there means I am taking 0 0 0 1 1 0 1 1. How many are there here? I am taking probabilities are 0 0 1 1. Here I am taking in place of 1 comma 0 I am taking minus 1. Why? Because the coordinate I am taking as a x. Here in 0 comma minus 1. Okay. So x minus 1, x minus 1 comma 1 and x comma y and 1 comma 1 y x plus 1 comma y plus 1. So these are the image, the sum of the products of the filter coefficients of the image pixel. So we have observed that the center coefficients of the filter w of 0 comma 0 aligns with the pixel at the location x comma y. So the general mask of the size m into n, assume that m equal to 2a plus 1 and n equal to 2b plus 1. So what is the equation? M equal to 2a plus 1 and n equal to 2b plus 1. So what is here? So the coefficient of the filter w of 0 comma 0 is pixel at location x comma y. The general mask is equal to m into n. The mask size is a m into n. So here for mask m it is equation, for n it is equation, and a comma b are the positive integers. And in general, linear spatial filtering of an image, the size is m comma n with the filter of size m into n. And the given expression g of x comma y equal to summation of s equal to minus 1 to a and t equal to minus b to b, w of s comma t into f of x plus s comma y plus t. Okay, where x and y are the variations of the pixel and w it is the every pixel in f. So the mask size is a m into n. So what is the need of mask means I am using for filtering process. So in the mask I am using in a filtering process the m equal to 2a plus 1 and n equal to 2b plus 1, and it is a odd filter. I'm using odd filter. Then the size is a m into n, and the equation g of x comma y is a output, and it is a input the filter function, filter, and it is a input. So output equal to filter method into input. So for input I'm applying the filter. For the input I'm applying the filter method. That is the output. So here also output g of x comma y equal to, I'm applying the input w of s comma t is equal to filtering process, and f of x plus s comma y plus t is a input, and total the size is a filter, and where x and y are varied, each pixel in w visits every pixel in f. So the image origin are image pixels. Here I am taking 3 by 3. So what are the coordinates? W of minus 1 comma minus 1, W of minus 1 comma 0, W of minus 1 comma 1, W of 0 comma minus 1, W of 0 0, 0 1, 1 comma minus 1, 1 comma 0, 1 comma 1. So total 9. Total 9 means okay, 9 coordinates. So what are that means? The center is a W of 0 comma 0, the center point. So these are the neighbors 1 2 3 4 5 6 7 8. So it is a 8 neighbor. Okay, so from this point of view, minus 1 comma 0, 1 comma 0, minus 1 comma 1, 1 comma 1, minus 1 comma minus 1, 1 comma minus 1, 0 comma minus 1, 0 comma 1. Okay, these are the filter coefficients. How many are means 8 coefficients are there. So f of x minus 1 comma y minus 1, f of x minus 1 comma y, I am taking this point of view. Minus 1 means x minus 1. Here minus 1 means x minus 1. 1 means plus 1. Here 0 means x. Minus 1 means y minus 1. Like this. Okay. So the pixels of an image section under filter. It is a spatial correlation and convolution. So what is a correlation and a convolution? So the correlation, the process of moving a filter mask over the image and computing the sum of products of each location. So convolution, the same process as correlation, except that the filter is first rotated by 180 degrees. Okay. So here I am taking correlation and a convolution. So what is a correlation and a convolution? We are going for the definition. So correlation, the process of moving a filter mask over the image and computing the sum of products at each location. So that is a correlation. And convolution, the same process as correlation, except that the image filter first rotated by 180 degrees. Degrees rotation. The image with a 180 degrees rotation. The same process, correlation, except that the filter is first rotated by 180 degrees. And the process of moving a filter mask over the image and computing the sum of products at each location. So here, what is the mask using in filtering? So mask is an imaging process method in which we define a small image piece and use it to modify a larger image. And masking is a process that is underneath many types of image processing, including edge detection, motion detection, and noise reduction. A mask is a binary image consisting of 0 and non-zero values. If a mask is applied to another binary or to a grayscale image of the same size, all pixels which are 0 in the mask are set to 0 in the output image. So masking is an image processing method in which we define a small image piece and use it to modify a larger image. And masking is a process that is underneath many types of image processing, including edge detection and motion detection and noise reduction. So a mask is a binary image consisting of 0 and non-zero values. If a mask is applied to another binary or to a grayscale image of the same size, all pixels which are 0 in the mask are set to 0 in the output image. Okay, 0 and 1. I'm applying the mask technique. Okay, so if I'm applying the 0, if I'm applying the mask 1, what is it? A mask is a binary image consists of 0 and non-zero. 0 and non-zero. If a mask is applied to another binary or to a grayscale image of the same size, all pixels which are 0 in the mask are set to 0 in the output image. Suppose I'm taking 0 mask, the output also in the 0. I'm taking 1 means the output also 1. Okay, 0 and 1. These are the input values and these are the output. Well, what is the process means? Mask technique. So mask for blurring. Mask is also using for blurring. So main concept is for blurring also in that. So the process of blurring, we reduce edge content of an image and try to make the transitions between different pixels intentions a smooth possible. Noise reduction is also possible with the help of blurring and forcing of faking eye contrast during conversation and imitating smiles and other facial expressions, mimicking gestures, hiding and minimizing personal interests, and developing a repertoire of rehearsed responses to questions. So mask is for main concept is for blurring. Okay, it is used for removing the blurrings. In the process of blurring, we reduce the edge content. We reduce the edge content of the image. So we are reducing the edge contents. Okay, and try to make the transition between different pixel intensities as smooth as possible. Noise reduction is also possible with the help of blurring and forcing or faking eye contrast during conversations, imitating smiles and other facial expressions, mimicking gestures, hiding or minimizing personal interests, developing a repertoire or rehearsed response to questions. So these are the applications of mask, and main concept is to remove the blurrings of the original image. And what are the general classifications? Smoothing, spatial filtering. Smoothing filter is used for blurring and noise reduction in the image. Blurring is pre-processing steps for removal of small details, and noise reduction is accomplished by blurring. So what are the types of smoothing spatial filtering? Linear filter, that is a mean filter. Order statistics, that is a non-linear filter. So smoothing, spatial filtering. In the previous we discussed spatial filtering. Okay, but now what are the types of spatial filtering? So types of spatial filtering means smoothing spatial filtering and sharpening spatial filtering. These are the two types. So first one, smoothing spatial filtering. Smoothing filter is used for blurring and noise reduction in the image. So blurring is pre-processing steps for removal of small details, and the noise reduction is accomplished by blurring. So what are the types? What are the types of smoothing is linear filtering, that is a mean filtering. Order statistics, non-linear filtering. So what is a mean filter? So these are the smoothing filters. So what is the use of mean filtering and what are the use of order statistics? So mean filter is a linear spatial filter, is simply the average of the pixels contained in the neighborhood of the filter mask, and the idea is replacing the value of every pixel in an image by the average of the grayscale levels in the neighborhood defined by the filter mask and multiplied by a higher value than the average filter. So mean filter, linear spatial filter. It is a mean filter is a linear spatial filter is simply the average of the pixels contained in the neighborhood of the filter mask. So the idea is replacing the value of every pixel in an image by the average of the gray levels in the neighborhood defined by the filter mask, and we are multiplying by a higher value than the average filter. Okay, that is a mean filter. And types of mean filters. Types of mean filter: average filter, weighted average filter, average filter, and weighted average filter. Okay. So average filter, it is used in reduction of the details of an image. All coefficients are equal. That is the average filter. Weighted averaging filter. In these pixels are multiplied by different coefficients. Center pixel is multiplied by a higher value than the average filter. Okay. So average filter and weighted average filter, these are under mean filter. But mean filter is under spatial filtering. Okay. It is a smoothing spatial filtering. So average filter is used in reduction of the details in image and all coefficients are equal. Weighted average filter, in this pixels are multiplied by different coefficients. Center pixel is multiplied by a higher value than average filter. Next, order statistic filter. It is based on the ordering of the pixel contained in the image area accomplished by the filter. It replaces the value of the center pixel with the value determined by the ranking result. Edges are better preserved in this filter. Okay. So the order statistics, it is based on the orders of the pixels contained in the image area accomplished by the filter, and it replaces of the center pixel with the value, and it determines the ranking of the result, and edges are better preserved in this filtering. So if I am taking the filter, edges are main preserving. Edges, main concept is for edges and blurring and remove blurring. So edges are better preserved in this filter. So types of order statistics filter: minimum filter, maximum filter. So what is the minimum filter? The 0th percentile filter is the minimum filter. The value of the center is replaced by the smallest value in the window. Okay. So when I'm taking the 0th percentile of the filter in the minimum filter, the value of the center is replaced by the smallest value in the value, and the 100th percentile filter is the maximum filter. The value of the center is replaced by the largest value. So maximum filter I'm taking for the largest. So 0 percentile is for minimum filter, maximum is for largest filter. So the minimum filter, 0th percentile filter is the minimum filter. The value of the center is replaced by the smallest value in the window. And maximum filter, the 100th percentile filter is the maximum filter. The value of the center is replaced and the largest value in the window. So median filter. Each pixel in the image is considered and the first neighboring pixel are sorted and original values of the pixel is replaced by the median of the list. Next, sharpening spatial filter. It is also known as derivative filter. The purpose of the sharpening spatial filter is just the opposite of the smoothing spatial filter. Its main focus is on the removal or blurring or highlight the edges. It is based on the first and second order derivatives. Okay. So when I'm going for the filtering, the median filter, already we discussed here minimum filtering, maximum filtering. Next one is a median filtering. So each pixel in the image is considered. First neighborhood or pixels are sorted and original values of the pixel is replaced by the median of the list, and smoothing is completed. Now we are going for the sharpening spatial So what is the sharpening? What is the use? So smoothing spatial filter is used for which purpose? And the sharpening spatial is used for which purpose? So sharpening is, the purpose of the sharpening spatial filter is just for opposite the smoothing, just opposite the smoothing. The main focus is the removal of blurring and highlight the edges. Here it is based on the first and second order derivatives. Okay. In the smoothing, we are adjusted. But in the sharpening, here removal of blurring and highlight the edges. And highlight the edges. So sharpening filter is a filtering technique for just opposite to the smoothing. What is the application means? Removal of blurring and highlight the edges. It is based on the first and second order derivatives. So first order derivative must be 0 in flat segment, must be non-zero at the onset of the gray level, and must be non-zero at along ramps. Okay. First order derivative is must be 0 in flat, must be non-zero at the onset of a gray level, must be non-zero at along with ramps. Okay. It is the first order derivative. And first order derivative in 1D is given by f dash equal to f of x plus 1 minus f of x. And second order must be 0 in flat areas, must be 0 at the onset and end of a ramp, must be 0 along ramps. Second order derivative in 1D is given by f double dash equal to f of x plus 1 plus f of x minus 1 minus 2 into f of x. Okay. So what is the first order filtering means? F dash equal to f of x plus 1 minus f of x. Second order derivative is f double dash equal to f of x plus 1 plus f of x minus 1 minus 2 into f of x. Okay. It is a second order. So what are the rules means? Must be 0 in flat area and must be 0 at the onset and must be 0 along ramps. So in that, I am using histogram. Already we discussed. Histogram is a computer image processing technique used to improve the contrast. It accomplishes by effectively spreading out the most frequent intensity values, that is stretching out the intensity range of the image. In any process, the histogram of an image normally refers to a histogram of the pixel intensity values. The histogram is a graph. It is to number of pixels in the image and each different intensity values to be found. Okay. So in the spatial filtering, it is directly on the pixel of an image. Okay. Spatial filtering is a technique used to directly on the pixel of an image. The mask is a technique is using in a filtering process and it has a specific center pixels. The mask is moved on the image such that the center of the mask traverses all the images of the pixels. So what are the classifications of the mask of the filter? It is a two types: linear spatial filtering, non-linear spatial filtering. So filtering is a spatial domain. The spatial filters are used in different masks, and the spatial filters can be used for linear and non-linear filtering. That is a frequency domain filters, just for linear filtering. The mechanics of spatial filtering consist of neighborhood, predefined operation, and filtering creates new pixels with the coordinates equal to the coordinates of the center of the neighborhood, and whose values is the result of the filtering operation. Okay, the operation performed on the image pixel is a linear. Then the filter is called a linear filtering. If I'm not applying the linear in the original image, that is called non-linear. So here I'm taking one 3x3 pixel, that is a 3x3 neighbor. Okay, so the response of the output g of x comma y of the filter at any point equal to x of y. So the output g of x comma y equal to the filtering process capital T into x of f into f of x comma y. So here T is a filtering or mask technique, and f of x comma y is a input process. The output equal to what is the technique you are using? Filtering technique, multiplication with input. Output equal to the filtering process with input. So it is one example. It is a 3x3 neighbor and x comma y, the spatial domain I am using. So here, what is the size of the mask equal to m into n? So the equation, assume that m equal to 2a plus 1 and n equal to 2b plus 1 and a comma b are the positive integers. The output g of x comma y equal to summation of s equal to minus a to a and t equal to minus b to b. W means here I am taking mask technique or filter process with f of x plus s comma y plus t. So it is a process of the correlation and convolution. So here we discussed what is a correlation and what is a convolution. So correlation, the process of moving a filter mask over the image and computing the sum of products at each location. And convolution means the same process as a correlation except that the filter is rotated by 180 degrees. When I am taking the 180 degrees rotation, okay, so this order is rotated with 180 degrees, I am taking as a convolution. So correlation is the process of moving filter mask over the image and computing the sum of products at each location. So mask is a process for the finding of the image piece and use it to modify a larger image. And masking is a process that is used underneath many types of image processing, include edge detection, motion detection, and noise detection. A mask is a binary image, consists of 0 and non-zero values. If a mask is applied to another binary to a grayscale image of the same size, all pixels which are 0 in the mask are set to 0 in the output image. So mask is for using for blurring. So when I'm using the process of blurring, we reduce the edges in content of that image and try to mask transition between different pixels, intensities, smoothing as possible. So noise reduction is also possible with the help of blurring. And the forcing and faking of eye conversation and imitating smiles and other facial expressions, mimicking the gestures, handling or minimizing the personal interest, developing a rehearse response to a questions. Okay. So what are the general classifications means? Smoothing, spatial filtering, and sharpening, spatial filtering. These are the major types of filtering process. So smoothing facial filters are the two types: linear filtering, order statistics. So linear filtering is a mean filter, order statistics is a non-linear filtering. Okay, smoothing filter is used for blurring and noise reduction in the image. So blurring is pre-processing step for removal of small details, and noise reduction is accomplished by blurring. Okay, what is the mean? The linear spatial filter is simply the average of the pixel containing of the neighbor of the filter and mask. The idea is replacing the value of the every pixel in an image by the average of the gray levels in the neighbor defined by the filter mask and multiply by higher value of the average filter. So mean filters are two types: average filter, weighted average filter. Order statistics filters are minimum filter, maximum filter, median filter, and the three types are there. And another major type is a sharpening spatial filter. It is a another type in spatial filtering. Okay, spatial filterings are two types already discussed: smoothing and sharpening. So what is the use of sharpening filter means? We are removing, blurring, and highlight the edges. Okay, here I am using first and second order filtering. So what is a first order filter means? F dash equal to f of x plus 1 minus f of x, and the second order filter is f double dash equal to f of x plus 1 plus f of x minus 1 in minus 2 into f of x. Okay, so these are the filter types we are discussed. Okay, so major thing is a smoothing and sharpening. Two types are there. So smoothing and sharpening filters. So in the smoothing, linear filter, order statistics, and the sharpening. So in the sharpening, we discussed what are the means. Sharpening filter means I am using first order and second order. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.